Okay, so today we're going to prove that for any sets A, B, C, and D, that A cross B intersection C cross D is equal to A intersection C cross B intersection D. So let's go ahead and draw a picture to illustrate how this goes. Okay, let me do a better job on that axis. Okay, so let's go ahead and have this be A, right? This whole section be A. And let's have some intersection. This section be C. So A intersection C is that little area here, right? And then let's go ahead and look at B intersection D. So let's go have here B and this B, D. So B intersection D is here. So let's go ahead. We know that A intersection C cross B intersection D, right, is going to be this area right here, right? So we're saying that this is the same as this, so let's just look at this geometrically, right? So we have A cross B. So A cross B is this right here. So this is A, right? This is A here. And then B is here, right? Oh, no, that's not B. Let me go back a little bit. So B goes up to here, right? Okay, so A cross B is this area here, right? And then C cross D is this area here. So this is C. And then D is here, right? So C cross D, so let's see, C cross D is this area here, right? Notice between this area and this area, their intersection is this area here, right? So at least we can see visually that A cross B intersection C cross D is equal to A intersection C cross B intersection D. So now let's prove it analytically, right? So prove. So we're going to look at this piece here. So A cross B. So we're going to have xy be an element of A cross B intersection C cross D. So by definition, this means, right, by definition of intersection, this means that xy is an element of A cross B, and xy is an element of C cross D, right? Okay, so what this means, right? So now let's start breaking this up. Actually, let me go ahead and give myself a lot of room here. So this tells me that x is an element of A, right? And y is an element of B. And, right, x is an element of C, and y is an element of D. So we basically have the form P and Q and R and S, let's say, right? So we know we can rearrange these any way we want because we know that the and connective is associative, right? So we can bubble these any way we want. So we know that this is the same thing as saying x is an element of A and x is an element of C and y is an element of B and y is an element of D, right? We know we can do that because this is equivalent to P and, so in this case it's going to be R, and let's see, P and R and Q and S, right? Okay, so of course this means that let's see, This means that X is an element of A intersection C, and Y is an element of B intersection D. And then if X is an element of A intersection C and Y is an element of B intersection D, this means that XY is an element of A intersection C cross B intersection D. Okay? And of course, this means, right? This means that for every XY, we have that XY is an element of A cross B intersection C cross D. If and only if, right? If and only if, I'm gonna not have enough room. Move it a little over here. Okay. If and only if XY is an element of A intersection C cross B intersection D, right? So if I have this, if I have XY is in here, if and only if XY is in here, this means that this must be equal to this. Okay, so that means that A cross B intersection C cross D is equal to A intersection C cross B intersection D. And that is the proof.